Right, what we're going to be doing in this video is I'm going to give you a quick overview of this electronics board that you're going to be using in a future lab, at least to the extent that we're going to be testing the proper operation of some diodes, transistors, and a component called a CDS cell. So I will be asking you to check this particular diode here. Now you may not be able to read the pin numbers here, but they'll be on your lab sheet. So there's a diode here I would ask you to check. And what we want is the forward bias and reverse bias readings. There's a couple other diodes here, all right, and I'll ask you to check those as well. And the transistors we're going to check, right here we have 4 transistors. I'm going to ask you to check 2 different ones. And if you'll recall, transistors come in the PNP or NPN form, and I'm going to expand on that knowledge here in a minute here in this video, so you know how to test these properly. And the final component I believe I'll be asking you to check is this one. You can see right here. It's called a CDS cell, cadmium sulfide. Now all of these other components you check with a diode checker, so the readings will be in volts. Remember to always put your units down. This particular component is an actual resistance reading that I want you to check. And the resistance of this component changes based upon the amount of incoming light to the sensor. Now the sensor isn't found here. The sensor is found, this may be a little out of focus here. So the sensor is found at the front of the board here. Now this may be a little out of focus, so I won't tilt it up any further. But right here in this section, you'll see a sensor. Got little wiggly S-shaped lines on it. That's it. That's where the sensor is located, and its connections are right here. So what I'll ask you to do is shine some light on that sensor, put your hand over it, cover it completely, and measure the resistance values that will change based on those different lighting conditions. What I'd like to do now is go over actual testing of these NPN and PNP transistors. So for that, I'll remove this board and I will grab a sheet of paper. All right, so what I have here are the 2 different types of transistors we'll be dealing with here in this course. One is an NPN and the other one is a PNP type. Now the operation of these 2 transistors are identical, except they just operate in opposite polarity terms. Other than that, they each have 3 leads. The 3 leads all have the same name, so that's a collector, that's the base, and that's the emitter. And you notice the only difference between these 2 transistors is the direction of these arrows on the emitter lead. And remember how I always started from your initial electrical course is because most solid-state components, at least the most simplest ones, have arrows on them, and they always point in a conventional current flow. Now that rule breaks down when you start looking at other types of solid-state devices, but it's a good initial start. So always think in conventional current flow terms, positive over here, negative to here on this particular NPN transistor. Now how do you remember which one is an NPN and which one is a PNP? Well, how I always tell people is NPN stands for never points in. So that arrow points away from the center of the transistor. And if you'll notice, PNP, we just shorten that to points in, right? And it's pointing towards the center of the transistor. Very easy way to remember which is which. So the transistor, I always start by saying it's nothing more, it can be nothing more than a 3-wire relay. Now, you know on relays we have the control side and we have the load side. So with only 3 wires, one of these 3 leads has to perform double duty. And in both cases, it's the emitter lead that performs double duty. This emitter lead on this NPN is part of the control circuit as well as the load circuit when we're using a transistor as a switching device. So the control circuit on this transistor, and actually on both, is the base and the emitter. And the load circuit is the collector and the emitter. So testing these, and I'm not going to actually give you the results and the look of the meter, I'm just simply going to use the red and the black lead in your field of view, and we have this turned to the diode setting because we check them just like diodes because they're not much more than slightly more complicated diodes. So let's take a look at how this NPN transistor works. So I had mentioned that the emitter performs double duty. It's part of the load side as well as the control side. So let's take a look at the load side first. So the load side on this transistor, in fact it's both transistors, is the collector and emitter circuit. And once you complete a circuit from positive to ground through this transistor, through the collector and emitter, you've completed the circuit to the load side, right? Basically, this section here needs to bridge that gap between the collector and emitter. And the direction of current flow has to be positive on the collector, on this NPN, to negative on the emitter. Now the control side, what turns this transistor on is the base in the emitter. The emitter has to say negative, which means to turn this transistor on. So in order to make this transistor allow current to flow from the collector to the emitter, you have to supply what we know in relay terms as the control side current. That's done by putting a positive charge on the base. Positive charge on the base, negative on the emitter. When that flows, when base emitter flows, collector emitter flows. And it's in that polarity that it has to be because this emitter is negative. So how you would check this is, there's a couple different ways. It doesn't make much difference. You put your diode checker leads, and again, I'm not going to have the DVOM in view. I'm just going to show you here and understand this is a diode check setting. So if I put my positive on the collector here and the negative on the emitter here, that's the proper polarity, but this transistor is not turned on because there's nothing connected to the base. But if we apply a positive voltage to that base, we will get current flow and you'll see it in your DVOM on the diode setting. So all you would have to do is take a wire, I'm going to use these set of tweezers right here, and touch that positive lead to the base lead. And that will turn on the transistor and you will get flow from the red lead to the black lead on your diode checker. And it will give you a certain voltage. And that's what we're going to want you to write down on your lab sheets. And that's really the simplicity of checking an NPN. And the PNP is no different. The leads have served the same purpose, but you have to switch the leads around. So you have current flow, conventional current flow, out of the positive, and it wants to go to the collector, which will be negative. Okay, so if I set that up like that, what am I going to have to place on the base to make this turn on? And by that, I mean, what polarity do I have to put on the base? Over here, we had to put positive on the base in order to turn on this transistor. You can see, if I've got positive here, this B needs to go to ground. So you take a wire, this is already your ground here, and just touch that point to the base, and all of a sudden this transistor will turn on, and you get a reading on your DVOM. And checking transistors is exactly that easy. Now I will note one more thing. You don't know where, or you haven't yet seen where the load goes. And the load always has to go on the collector side. If you put the load over on the emitter side, you can think back to your relay understanding, and you never have the load on the control side. So if our control side is base emitter on both, you cannot put the load over here. It only works when the load is on the collector side. So over on this diagram, the power would come to the load first, go through the load, and then attach to the collector, and then it would go all the way direct to ground when this transistor turns on. It's the exact opposite on the PNP. You have positive here to the emitter. It's waiting to go through, and when it goes through, your load will be here, so the collector provides a positive voltage to your load, and the other side, it just goes straight to ground. You can see one is just the opposite of the other.